on your slides there, you have in your equations, anyone, that one, no, not that one further one's on. Go back to the one you just, no, again.
Stop.
Just stop when you get the building, thank you. Okay, on here where you've got your regression equations, how did you calculate those equations? How did you come to have that equation? Because see, if I take that second one there, 14.37 plus 0.09 multiplied by NDF, how did you come to arrive on the 0.09?
Can I come up with this impression here?
Yes.
I used the model, regression model, to plot the diameter intake and NDF. So to come up here the equation and relationship between them. So when I put the data, one column for diameter intake, one column for NDF, and then plotted them in the diagram, and I can see the equation come up.
Okay. So it was generated by the computer. From your results that you put in there. Thank you. Yes? You have a question? No?
No, I'm just a record.
You say your R squared there is, you're only picking up, so we'll go back, use that same equation, 0.21% of the variance reading of it. But yet that's highly significant.
Yeah.
Is that? So if you go back to some of your, where you plot them.
When I use a model to plot the diameter intake and environment temperature, for example, in the first equation here, even though it's significant with a p-value less than 0.01, but the R square accounted for this relationship was 50%. So when we look at the relationship, we make sure that the p-value less than 1.05 to make sure that they have relationship. But the strong relationship, but this one for the R square here accounted for only 50%, so that they don't have very strong relationship.
I think it shows up as significant because there's so much data.
Yeah, all right. So that's fine because I've got the panel.
So significant to
determine
that they have relationship, but the R square show that they have strong relationship or minor relationship. So for the R square, more than 50%, we can say they have very strong relationship.
So if you just show us one of your diagrams, just show one of your diagrams. You'll see if you look at that, your R square there is 0.1.
Yes. Only 80%.
Yeah.
80%. Yeah. So because what
you look at some of these others, I mean.
When I look at the relationship between diameter and temperature, it was very clearly to show that they have a strong relationship. The temperature increased, the temperature here increased, and diameter decreased. With the R square for them was 30%. But when I look at the relationship between feed quality and environment temperature, the R square for them only 8%. So I can't really explain why that happened. But I can say that more research needs to be done to investigate the relationship between temperature and feed quality in the future.
So you've got a powerful data set in that you've got a lot of observations.
Yes.
That's the
How much protein was there in the animal's diet? Do you know?
The protein in the diet, that depends on the partial protein content or TMR protein content. Because the TMR protein content quite high when they have like cotton seeds or soybean meal. Yeah.
So I'm just wondering, because protein increases metabolic heat, doesn't it? So
fibre components and everything.
Yeah.
I would have thought.
See, the problem, one of the problems here is that they won't graze
Yeah.
during those periods. So
Yeah.
if you go back to like
Yeah.
pasture dry matter intake, it's only 2 kilos or something.
Yeah,
And
yeah,
that's about right. So
yeah.
most of the nutrients coming out of the TMR, the cows are actually probably in negative energy balance for a long period.
So I know you put up a conclusion, but if you were to walk out of here now
Yes.
and design another experiment, what would you do?
Firstly, I need to do like, I need to monitor the feed TMR, actual amount of feed the cattle consume per day. Because what I have done here, I rely on the feed sheet recorded by staff. So they might put exact number or not really exact number the cow consume that day. So that might affect the pasture diameter intake. Because when I put the data on NRC research, National Research Council program, and I found that the pasture diameter intake consumption was very low. That means the TMR, the cow consumed very high amount of feed. So I have to monitor the actual feed that cow eat every day. So I better to estimate pasture diameter intake.
So individual cows.
Yes.
And do you think that the equations that have been developed by the NRC are relevant to our situation?
NRC was developed quite a long time ago. And now the people have more software and program to estimate more accurate the pasture diameter intake. But what I have got here, the NRC, I have a reference for it. For the new software, I don't have a reference for it. And also, in my thesis, I also stated that NRC also was sort of error to my